fellow student, I'm Miss Ngubane from Umgungundlovu FET. I will be taking you for N4 Building and Structural Surveying. We'll be doing Module 3 under the topic Areas and Volumes. So at the end of this lesson, you should be able to identify the suitable formula because we've got different types of formula that we use when we are calculating the area. So you need to identify the suitable formula. You also need to be able to calculate the area of the triangle, trapezium, and also the volume of the trapezium. Okay, for prior knowledge, in N3 level, you learned about different types of polygons, which may include a square, a rectangle, a parallelogram, and trapezium, and also the polygons that got more than 4 sides, which can include pentagon, hexagon, and octagon, etc. So today we'll be calculating the area of what of the triangle as well as the trapezium polygon. Okay, let us go to areas. So someone can have a question, why do we necessarily have to calculate the area? We calculate the area to subdivide the land and establish new boundaries. For example, let us say I'm given the piece of land that is in this shape, and I'm required to calculate the total area of this plot of land. Okay, so the first thing that I need to do, I need to subdivide to create what? New boundaries. So now I would have area A, area B, and area C. So I would first have to calculate area A, area B, and area C. And then when I'm done that, I would add area A plus area B plus area C to find the total area of this plot of land. Okay, so areas are measured in square meters. So remember, when we are doing calculations for areas, they are measured in square meters and in hectares. The formula to calculate the area depends on the shape of plot of land or the landscape. As I mentioned before, that we've got different types of formulas that we use to calculate what? The area. So it depends on the shape of the plot or of the landscape, which could be triangle, rectangle, trapezium, circle, segment, polygon, and irregular shape. So each shape has its formula that you need to use when you are calculating the area. For volume, when calculating volumes, the area calculation is done first, which means when you are required to calculate the volume, you first need to calculate what? To calculate the area. When you are done calculating the area is then used with the depth to find the volume. First, you calculate the area, and then you have to calculate what? The depth of excavation in order to calculate what? To calculate the volume. The formula that we use when we are calculating the volume is equal to area times depth. The standard unit of measurement of the volume is in cubic meters. Okay, so today we'll be calculating the area of the triangle. Why did I choose the area of the triangle? It's because it's got 3 different types of formulas. So it depends on the types of triangle that you are given, or it depends on the information that you are given. Okay, so there are 3 methods for calculating the area of the triangular shape with different formulas. Okay. Where else, when we are calculating the area of the square, we've got 1 formula. And when we are calculating the area of the trapezium or parallelogram, we've got 1 formula. But here on the triangle, we've got 3 different formulas. Okay, so let us first look at the first method. We use the formula area is equal to half breadth times height when the baseline and the perpendicular distance are known. Okay, let us look at the example so that you will find what is being required here. Calculate the area of the triangle ABC with the baseline BC equal to 80 meters and the perpendicular distance between A and baseline BC is equal to 40 meters. Okay, here we've got what? We've got the baseline, which is 80 meters, as well as the perpendicular distance, which is 40 meters. Okay, the first thing that you need to do, you need to draw a rough sketch of your triangle, okay, using the information that you are given. Okay, we were told that we've got the baseline, which is equal to 80 meters, and we've got the perpendicular distance. Since it's perpendicular, it forms 90 degrees here. We've got the perpendicular distance here, which is 40 meters. So if we are given the baseline as well as the perpendicular distance, it's whereby we use the formula area is equal to half breadth times height. Then you can now substitute these values on this formula. Okay, let us look at here in our solution. So you first need to draw a freehand sketch, then you calculate. So your formula is area is equal to half breadth times height. Then you would have half into your breadth, which is your baseline, is 80 meters, times your height, which is a perpendicular distance, which is 40. Then you will get 1,600 square meters. Okay, let us move to another method, which is the second method, where we'll have the different formula than the one that we used there. Use the formula area is equal to square root S into S minus A into S minus B into S minus C when the length of the side of the triangles are known. So if you are given now the triangles and you were told all the length of the triangle, then you need to use what? This kind of the formula. Okay, so the first thing that you will first need to do is to draw your freehand sketch of what? Of your triangle. Let us draw here a freehand sketch of the triangles. And let us look to the example here. The example said a piece of land shaped as a trapezium has the side of 60 meters, 100 meters and 140 meters. Calculate the area of the land. So we were given three sides, which is 60 meters, 100 meters and 140 meters. So on your freehand sketch of your triangle, you need to name your triangle. You can name it as angles. You use capital letters here. For angles, it's A, B, and C. And for side, we use small letters. Then the side that is opposite the angle A, it will be A, small a. And the side that is opposite to angle C, it will be the small c. And this one, it will be the small b. So our first side, we were told that it is 60 meters, and B is 100 meters, and C is 140 meters. Okay, so now you have your rough sketch of the triangle. Okay, let us go back to the formula that we need to use. As you can see here, we need to use this kind of the formula. But on this formula, we don't have the value of S. That's why we first have to calculate the value of S, which is the total of the sides. Okay? So we first need to calculate the value of S because we now have A, we have B, we have side C. The only thing that we don't have is S. the total side of the triangle. So when we are calculating the total side of the triangle, we use this kind of the formula, which is S is equal to A plus B plus C divided by 2, which A is this side 60 meters plus B, which is this side 100 meters plus C, which is that side 140 meters. Then you will get 150 meters. Okay, now we can use our formula that we use when we are calculating the triangles, knowing all the three sides, because we now have the value of S. So we need to substitute on that formula. So here you said area is equal to square root of 150 meters, which is the total number of sides, times 150 minus 60 into 150 minus 100 into 150 minus 140, which will give us 2,598,08 square meters. Remember, we are calculating for the area. That's why the unit measurement should be in square meters. Let us go to the third method now. We use the formula area is equal to half BC sine A. So be careful here. It won't be always BC sine A. It can be AB sine C, okay? You don't have to cram it as it is. Okay, when two sides of the triangles are included and included angle are no. So we use this kind of formula when two sides of the triangles and included angles are known. Okay, so let us look at the example here. Calculate the area of the triangle plot with the side AB is equal to 280 meters, AC is equal to 350 meters, and the angle BAC is equal to 30 degrees. Okay, we need to draw our freehand sketch of this triangle. Okay, we've got line AB, which is 280 meters. And also we've got AC, which is 350 meters. We've got C here, we've got AC, which is 350 meters. And we were also given the included angle, which is 30 degrees. So our formula here is area is equal to half BC sine A. So what we need to do here also, you need to name your side. Okay, this is angle 90 degrees, and the opposite side here it will be a small b, and the opposite side for angle 30 it will be a small a, and the opposite side for angle C it will be the small c. Okay, so what you need to do now, you need to substitute all these values in your area formula. Okay, so what you need to do now, you need to substitute all the values that you have put on the rough sketch into the area formula. Okay, your B here is not 240. Let me change these values here. So B is equal to 350, and C is equal to 280. Yeah, now we've got the correct values. So our answer here will be 24,500 square meters because we were calculating for the area. That's why our unit measurements are in square meters. Okay, let us go to areas of polygons with more than 4 sides, which can include pentagon, octagon, and hexagon, etc. Okay, let us look at the example here. Calculate the area of the regular hexagon with the side of 32 meters in length. Okay, we were told here that we are required to calculate the regular hexagon. Okay, so the first thing that you need to know, you need to know the shape of what? Of your hexagon. Okay, first you draw the rough sketch of your hexagon here. Remember, there are no marks for the rough sketch. Okay, so now you've got your freehand sketch of your hexagon. Okay, so we've got our formula here, which says area is equal to s squared times n divided by 4 tan 180 divided by n, which n stands for the number of sides. And S stands for the length of the side. S stands for the length of the sides. Okay, so we've got this kind of formula, so we need to substitute on this formula. Okay, then we will have your S, which is the length of the side. We are told that the length of the side is 32 meters squared. Then you times by the number of side, which is 6 divided by 4 tan into 180 divided by the number of side, which is 6. And then your answer will be 2,660,430 square meters. Okay, let us go to this example where we'll be required to calculate the area as well as what? As well as the volume. This is the example of the exam questions. Okay, the average height of piece of land in the shape of the trapezium is 250,5 meters. Calculate the volume of earth to be removed if the following information is known. The level is to be reduced to 240,0 meters. The long side of the trapezium is 46,0 meters and the short side of the trapezium is 32,0 meters, as well as the perpendicular distance between the 2 points is 44,0 meters. Again, you need to draw the freehand sketch of what? Of your trapezium. You are told that you have the short side, which is 32,0 meters, as well as the long side, which is 46,0 meters. We know that the short side and the long side are parallel to each other when you are drawing what? The trapezium. Okay, we are also told that the perpendicular distance here between these two distance or these two sides is 44,0 meters, which is the height of the trapezium. Okay, so what you need to do, we are required to calculate what? The volume. I've said earlier that we first need to calculate what? The area. Okay, the formula that we use to calculate the area of the trapezium is area is equal to A plus B, which is this side. We can name this side as A and this side as B, divided by 2 times height. Okay, our A, our short side here is 32,0 plus our long side is 46,0 divided by 2, and our perpendicular height here is 44,0 meters. Okay, let us look at the solution here, and our answer here will be 1,716 square meters. Our answer here will be 1,716 square meters. We are not done yet. We still have to calculate what the depth of excavation. Depth of excavation. The depth of excavation is equal to what? Is equal to the average height. Let us go back to the question. Our average height is 250,5 meters, 5 meters minus the reduced what level? Our reduced level is 240,0 meters. 240,0 meters. And then we'll have 10,5 meters. So the depth of excavation is equal to 10,5 meters. Okay, we now have the area, we now have the depth of the excavation, so we can now calculate what? The volume. The formula for volume is equal to area times the depth of excavation. Our area here is 1,716 square meters times our depth of excavation, which is 10,5 meters, which will give us 18,018 cubic meters, because now we are dealing what? We are dealing with the earthworks. When we are calculating for the volume, the unit measurements are in cubic meters. As you can see, this is the solution here. Okay, all in all, when we are calculating the area, we want to subdivide the land and create new boundaries. Areas are measured in square meters. When calculating volumes, the area calculation is done first. The area is then used with the depth to find what? To find volume. The formula for volume is equal to is equal to area times depth, and the volumes are measured in cubic meters. That was all for today, but let us quickly go for recap so that I can emphasize the most important points on this section. Okay, so remember, you should be able to identify the suitable formula. Since I've said earlier that we've got so many types of formula that we use when we are calculating the area, so you must be able to identify the suitable formula in order to solve a particular problem. And also, you need to know every time when we are dealing with areas, areas are measured in square meters. Okay? For the volume, if you are required to calculate the volume, the first thing that you need to do, you first need to calculate what? You first need to calculate the area. When you are done calculating the area, you need to calculate the depth of excavation, because we want to know how deep the trench will be. Okay, you need to calculate the depth of excavation before you calculate what? You calculate the volume. Remember, this is the exam question. So in exam, they usually ask these kind of questions. Okay, and don't forget to leave the unit measurement, because here, if it was 18,018, just only, you didn't put cubic meters, then your answer will be wrong. You should always put your unit measurement. When you are Calculating for volume, the unit measurement for the volume are in cubic meters. And also for triangles, you should see what you are given so that you'll be able to know which formula you should use. Okay, let us quickly go to the third method. I think this formula confused most of the students, but here on BC, u times the two sides that they give you, u times the two sides that includes the angle that you are given. You are given the angle, so you need to times those two sides that include that angle. Okay, you should not confuse yourself here. You can name it anyhow, as long as you're gonna know that you need to times here the side that includes what? The given angle. And for here, for sine A, for A, you put the angle that you are given. And again, when we have to calculate the area of polygons with more than 4 sides, you should be able to know the different types of polygons that's got more than 4 sides: hexagon, octagon, and hexagon. Okay, so you should know so that you will be able to identify the length of the side as well as the number of the side, because if you don't know that the pentagon has 5 sides, then you won't get the correct answer. So thank you so much for listening. Please stay at home. We love you so much.